So this chapter is 2E, the area of a parallelogram and a trapezium, or a trapezoid. Two skills. You will learn to calculate the area of a parallelogram and how to calculate the area of a trapezium. So, a parallelogram versus a trapezium. A parallelogram has two pairs of parallel sides. So, if we look at a rectangle, this side and this side, they are parallel. Actually, the marker would be a little arrow. And then this side, which is marked by a double arrow, is parallel to that side. So these little arrows are signs of what sides are parallel. So if we look at a rhombus is basically a tilted square. This is parallel to that one, where this double arrow is parallel to the other side. Or if we look at a square, parallel, parallel. And so there's always two sets of parallel sides. Now, a trapezium only has one pair of parallel sides. So the traditional trapezium that we all might know is an isosceles trapezium, where both sides of the diagonals are about equal length, not based on my diagram here. And so this side is parallel to this, because if I were to extend my line, it just keeps going. And parallel lines, remember, are lines that just keep running and they never ever intersect. So they're kind of like train tracks. Some trapeziums might look something like this, or even sideways, like this. And no matter what, there's always going to be one set of parallel sides. And did you know that two trapeziums make one parallelogram? So if I were to, if I were to draw the same version of this parallelogram on top, there you go. Two trapeziums make one parallelogram. Now, to find the area of a parallelogram, it's very much like working with a quadrilateral. It's simply just base times height, but the height is particular. It's the perpendicular height, again, going straight up and down, perpendicular to the base. So at this time, pause and find the area of a parallelogram. So it will be area is equal to 16 centimeters times 8. 16 times 8 is 128, and its area, centimeters squared. The area of a trapezium has a slightly more complicated formula, and we can talk a little bit about it. So basically it works like this. You have to first add the two parallel sides together. So here's one parallel side, here's the other parallel side. So we will call one A, the other one B. And then you have to multiply it by the vertical height. So in this case, 8. And then finally, you know how it says to multiply to 1/2? Multiplying by 1/2 is actually equal to dividing by 2. It's the same thing. So if I ever said times by a 4th, did you know that that's the same thing as saying divide by 4? That's a side note. But anyhow, timesing it by 1/2 is just basically dividing it in half. So what we have to do here is take the two parallel sides, 12 plus 22, multiply it by the vertical height, 8, and then divide it all by 2. So if we break this down, the area is equal to 34 times 8 divided by 2, which comes down to 272 divided by 2. And if we simplify this fraction, this basically makes 136 centimeters squared. And the reason why this formula works, here's a little theory for you, is because of what I said in the previous slide. If I were to take the same trapezoid and stack it on top of itself, I basically would have made a parallelogram. So we have to add the two bases because this is 12 and this part technically is 22. And then the height, it doesn't change. And then so if we were to do 12 plus 22 times the height, we would get our whole parallelogram, right? But since it's a trapezium and we want only half of it, that's why we divide by 2 or multiply by 1/2. That's a little fun fact for you. And that's it.